Okay guys, this video is for Honors Algebra 2. It is 8-3, which is graphing reciprocal functions. So starting off with a pretty important slide, a reciprocal function has an equation of the form f of x equals 1 over a of x, where a of x is a linear function and not equal to 0. So basically what this means is your reciprocal functions will have some number in the numerator and it will have a linear function in the denominator where it does not equal 0. So basically you're talking about things like 1 over x plus 2 or 7 over x plus 1, stuff like that. As long as you have a number in the numerator and a linear function in the denominator. So these look really weird. The type of graph is called a hyperbola. So if you look at it, this is the picture of it. This is your parent function of it, which is 1 over x. So this is what it will look like. Your domain and range are all non-zero real numbers as far as the parabola goes, or the parent function goes rather, sorry, because your denominator can't be 0, right? So x cannot equal 0, and then so therefore you won't get a y of 0 either. So that's where your asymptotes come into play. If x equals 0 right here and y equals 0 right there, as far as your asymptotes of the parent function. The domain of a reciprocal function is limited to the values for which the function is defined. That basically goes for what we just said. You're going to fall into where your denominator cannot be 0 once again. So those types of questions are going to still hold true as far as these types of functions go. You have to make sure that your denominator, you have to figure out what value your denominator cannot be, because that value will end up being an asymptote of these functions. So to start, before we start actually graphing these, we have a couple of examples here to determine the limitations on your domain. So determine the value of x for which the functions are not defined. We have 3 examples here. The first one is 3 over 2x plus 5, and the way we're going to do this is you take your denominator, which is 2x plus 5, and that guy cannot equal 0. And so you solve that equation. So subtract 5 from both sides, so 2x can't equal negative 5, and divide by 2, x cannot equal negative 5 halves. So when we would go graph this one, the asymptote would be at negative 5 halves for that one. Number 2, once again, if you can do this without showing work, for example, x can't equal 1, like that for number 2, that's fine. So number 3, f of x equals 7 over 3x plus 2 is your first question there. Determine the value of x for which the function is not defined for the last one. Okay, hopefully you got x cannot equal negative 2/3. So this is how you do them algebraically. You just look at the denominator, and then that tells you where the asymptote is for x. It tells you what number you can't put in, which is why there will be an asymptote there. As far as the graphical representations go, so now we have a different kind of function, different kind of question. We are going to identify the asymptotes, domain, and range of each function. So the function that they give us is g of x equals 1 over x plus 2, and then a minus 1 after that. So you're looking at 2 different asymptotes for these. First you look at your vertical asymptotes, and then secondly we're going to look at your horizontal asymptotes. For your vertical asymptotes, that's where the vertical line that the graph approaches but never crosses. So these, to kind of start off, I'm going to have you look at the graph. If you look at these graphs, they kind of curve this way, and they curve down, 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 and then this one they curve up, up, and up, and up, and it never touches this line right here. So I'm going to do my best to kind of draw that with a neon green right here. Okay, now remember, when you draw it, it might look like it touches, but in reality, it always gets closer and closer, but never does. So since that line is vertical, it's an x line, it's an x equals, and it ends up being x equals negative 2, because it's 2 to the left. Where you get that from your equation is from the denominator right there. X plus 2 cannot equal 0. So the line is x equals -2. That is your asymptote line. Okay, so remember, these are actual equations of lines at this step right here. Alright, now looking at the graph for your horizontal, there's a horizontal line where it also approaches but never crosses. And there'll be one of each for every one of these graphs today. So each one of these graphs will have a vertical asymptote and a horizontal asymptote. This horizontal asymptote, if you look at the graph, the blue line approaches this line here this way, approaches this line right here this way. So it's this line right here that is your horizontal, which is the line y. That was a terrible y. Let's try that again. Y equals -1. And that comes from this part of the graph right there. Okay, so your vertical asymptote is x equals -2. Horizontal asymptote is y equals -1. So that's the identifying the asymptotes part. These two lines right here. I'll circle those in blue. Alright, but it still wants us to state the domain and range of each function. Now to do that, we're going to change the notation a little bit. We're going to fancy it up a little bit. We're still going to start with a D. But now we're going to go to what is called set builder notation for these. And it's a little weird at first, but you'll get the hang of it. So you start with a brace. Okay, practice drawing braces. It takes a while, so I'm going to have you start practicing now. Your domain involves your x's, so your x goes next. And then you draw this vertical line. And that vertical line basically means x's for which. Okay, so it's a little weird notation. That vertical line means for which all x's, and then you finish off with what x cannot be. So in this case, since the horizontal or the vertical asymptote is the line x equals -2, the number you cannot plug into your function is -2. Okay, so I know it's a little confusing why this one's equals and this one's not equals. Know the difference. Here we're talking about the actual imaginary line itself, which is in this case this green line, which is the vertical line x equals -2. So that's why this is equals. When you actually state the domain, you're talking about excluding that number because you can't plug -2 into this function. So in the domain statement, x cannot equal -2. That's the difference. You're talking about a line up here, but down here you're talking about what number you cannot put into the function. And then we do the same for our range. If you look in the book, they may do it as f of x, which I'm going to as well. So f of x, the domain, is f of x for all f of x is not equal to -1. And that's your domain and your range. Okay, so you need, whenever you're given a graph, you need to put both. Alrighty. Sometimes you'll be given the graph and you're going to get one here and coming up where you do the exact same thing. A little bit later you're going to actually have to graph them and show the asymptotes themselves. Okay, so this one right here for g of x equals 2 over x plus 1 plus 5 on the outside. Do the exact same thing. Identify the asymptotes, domain, and range of each function. The question is going to ask for the first one. You'll see there's two questions. Okay, so the first one's going to ask for the vertical asymptote. The second one will ask for the horizontal asymptote, and then I'll show you the domain and range after the question. So for question 1, put in the domain, or not the domain. Sorry, messing up. For question 1, put in the vertical asymptote, and for question 2, put in the horizontal asymptote. Okay, so for the vertical asymptote, you should have the line x equals -1. And then for your horizontal asymptote, you should have the line x equals 5 coming from here and from here. The domain and the range, if you look at the set, like I said, braces take practice writing. So if x is for all x's that do not equal -1, The range is f of x for all f of x's that don't equal positive 5. Okay. That moves us into this slide where we talk a quick little bit about transformations. And the reason why I say a quick little bit is because it's pretty much the same as every single transformation we've done to this point. So we were talking about a over x minus h plus k. K does your vertical shifting, h does your horizontal shifting, where it's the opposite that you see. You probably figured that out already. And a stretches, compresses, and flips. So if you look at the differences between those and your parent functions, which is 1 over x, it's the same kind of deal. It's shifting everything. It shifts the asymptotes too, in case you didn't make that connection with the past two that we've done. So remember to check your transformations because that's where it's going to be shifted whenever you start graphing, and which is what we're going to do next. So graph each function, state the domain and the range. So we're going to start by graphing f of x equals 2 over x minus 4 plus 2. Okay, so the first thing we do, we're going to look at the function and we're going to get our asymptotes. So we look at our denominator of the function for our vertical asymptote, and then we look at the outside number for our horizontal, the outside shifting number. So your vertical asymptote, remember, is going to end up being where your denominator equals 0. In this case, the line x equals 4. Your horizontal asymptote will end up being this outside number here, which is the line y equals 2. And then on your graph paper, hopefully you got a little bit of graph paper, you made a quick graph, draw those vertical lines and draw them like dashes, okay? Because dashed lines kind of signal they're imaginary lines, and that's what these are. These are imaginary lines, so I'm going to go over to x equals 4, which is right here. I'll do my best without going to the straight line generator. There we go, that's not bad. And then go to y equals 2 and do the same. Okay, so there's the two asymptotes. So our graphs are going to approach these two asymptote lines. Now from here, if you notice, this breaks up your graph into basically like 4 sections of, so 1, 2, 3, 4. And I notice how I'm drawing them like within all the actual coordinates of the plane because I'm talking about the red lines breaking it up. So for reciprocal functions, this is always the case. You'll always have 2 asymptotes, therefore you'll always have 4 sections of your graph. Now basically what you do is you talk the domain and range the same way we did last problem, and I'll come back to this in a second. So you do the domain as all x's for which x does not equal 4, and your range, oops, there you go, is f of x's for which f of x does not equal 2. Okay, judging by these asymptote lines. So now your last step to actually graph it is to basically go on your calculator and plug this in and see where it is in the general shape. Alright, so I already have that wrote down on my paper, and then I'm going to draw it up here real quick just to show you. Ends up being about right like that, and then kind of like that. That was really good. So that's how it ends up looking, and I'll show you how to plug this into your calculator at first. Basically what I'm going to look for when you graph these is that you get the general idea of the shape of the graph. For example, I'm going to do this in green, so don't do it. If it's supposed to look like this, I want to see it somewhat like that. I don't want to see your graph look like that, essentially. So as long as you get the general closeness of the graph and the correctness of it, and on the right sides of the graph, I'm probably going to give you credit for it. I'm looking at your domain and range, general shapes of graphs, and your asymptote lines. That's what I'm looking at. So let me make sure you write this down if you haven't done so already, because it's going to go away real quick. In 3, 2, So let me show you how you plug this into a calculator. You basically need to make sure, just like with anything, when you hit y equals, just make sure that you group that division. So 2 divided by parentheses on the denominator, x minus 4, close them parentheses, which groups the fraction there together, and then a plus 2 after that. And then you hit graph there, and hopefully, yeah, see that? It looks pretty close to what we just drew on our paper. You'll notice the major difference is this: it doesn't give you the asymptotes on your calculator. Okay, and if you look very closely at these, it looks like, it just starts here at that line and then keeps going. So it's important on your paper to figure out what the asymptotes are, because it's kind of hard to figure it out on a calculator. You can usually get your verticals pretty good, but your horizontals usually end up being a little bit more of a pain. So make sure you get your asymptotes before you graph it. Just to show you why I don't want to see anything else really. If you look at the table of these, they're just ugly. So it's not important for me to see that you have the table, because at this point in your careers, I'm assuming you know how to use your table function. Like, see, we have a couple of nice numbers, but that's about it. And everything after that, if you look at 4, that's why, see how it gives you the error on 4 right there, because 4 was one of our asymptotes for our vertical. So you can kind of see how these numbers really become ugly at this time of year. So it's not super important to get the exact number pinpoint. I want to make sure you get the general idea of the shape of the graph and stuff like that. Alright, so the last one here, you have graph each function, state the domain and range. Basically, you're going to see 3 different questions pop up with this one. The first 2 are going to be, just like last one, figure out your asymptote. So it'll be question 1 will be your vertical asymptote, question 2 will be your horizontal asymptote, and then question 3 you'll see once that we get done with those. So answer 1 and 2 with your vertical and horizontal asymptotes on this guy first. Okay, so hopefully you put in the vertical asymptotes at x equals -1 and y equals -4. And then I just went ahead and did domain and range too. It's a little hard to put that in for an answer, so I'm not too. We'll work on this in class to make sure everybody understands this. But I didn't feel like it was fair to ask you questions over it. So we're going to go ahead and draw those asymptotes. Okay, so right here's one. At -1 on x, and then we got one at -4 on y, kind of like that. Okay, and the question I'm going to ask you next is I'm going to write them blue numbers. 1, maybe not blue, let's go with, let's just do red. 1, 2, 3, and 4. And the question is going to be, what 2 of those sections is my graph going to appear in? So which 2 parts of that 4-parted graph, according to my asymptotes, will the graph show up in? Not the coordinates of the quadrants of a coordinate plane, but sectioned off with the asymptotes. So down here is 1, up here is 2, over here is 3, and down here is 4. What 2 sections does my graph show up in? Okay, so hopefully you put down sections 1 and 3, right here and right here. Notice how the ends of these don't get as close to the cross point of the asymptotes. So hopefully your graph kind of curves out a little further away from these intersections than the old one did. Like I said, as long as it looks close, looks somewhat decent, you'll probably get full credit for it. Maybe this one down here, honestly, I have a little too close, to be honest. So let's try that one again real quick. Maybe something a little more like that instead. So like I said, I'm not looking for exact, but I might take off a point or a half point just for, if you're a little off. So try to get as close as possible, but like I said, exactness we're not too worried about. That's essentially this lesson, this video. A lot of these concepts roll over into 8.4, which is a little tougher. So make sure these concepts are good so 8.4 goes well. Your homework for this one is page 549, numbers 7 through 22.